Huzur, thanks a lot for, I didn't realize you were going to actually give a long introduction. So I actually sometimes forget who I am. Am I an academic in industry? And now actually I don't even know whether I know. I seem to be some combination of an academic who seems to be in an industrial R&D setting and now an entrepreneur and some mixture of that. And so what I thought I will do today is tell you a little bit about what I have been learning over the last few years as to where this entire our industry is going and what are some of the opportunities, what are some of the driving factors and what opportunities it is actually offering to us as sort of an innovations community. And I want to end with some probably open challenges. So I want to start sort of very high level and I'll keep drilling down as we go through. So, and a lot of what I'm going to tell you is a lot of lessons learned. So I came, so as Huzur mentioned, when I came back to India in 2005, I was working deeply into network protocols, network architectures, I mean, all kinds of things, and joined TCS and TRDC, which is our largest R&D center, and had the opportunity to probably go and see some of the largest companies globally and understand where the problems are and what are the problems that they're facing. And so that whole learning experience has sort of brought me where we are, and I'll sort of walk you through that journey. But let me start by actually saying that today we live truly in interesting times. It's probably unprecedented in at least history in terms of the rate at which things are changing. If I actually look back and last 25 years, in 25 years you have seen many things come and go, disappear. And they're actually an astonishing list, just to actually put this in context. So by the way, this discussion today is a little bit broader than networking, but you'll actually start seeing the ripple effects of that across the entire ecosystem that we live in. So let's start with simple examples, things that have disappeared, right? And within the last 20 years, right? Today, there are no phone boxes anywhere. It's interesting, right? In fact, just 2 months ago, I landed at an airport and my phone didn't work. And I had no idea what to do. Because I have no numbers, I've forgotten, no record of anything, and no such phones available anywhere, right? And at a place where I don't speak the local language starts becoming an interesting challenge. But this has disappeared. There are many such things that have disappeared, right? Your film-based cameras or photography has actually disappeared. Maps have disappeared in that form. In fact, maps in digital form are also actually somewhat disappearing because they are actually getting substituted by recommendation systems, which are essentially telling you what to do. Nobody actually sees maps. You simply follow Google advice. Nobody questions, right? So even the skill to see a map is probably going to disappear very, very soon. Right, so very interesting. You keep following. CDs, right, have come and are rapidly disappearing, right? So in fact, there is no physical media for BlackBerry. Interesting, right? The first generation of smartphones have come and gone. 2007. Or 2005, 2006, I should say. This was the dominant platform, less than 10 years ago. Right? It has disappeared. In fact, BlackBerry has stopped manufacturing. And this list actually goes on, right? I mean, most interesting, recent one, the most recent, 2012 SMSs. If you actually go back and look at a lot of the telecom providers' business plans of 2012, it's a very interesting graph that you would actually see. They're all projected that the voice calls were actually not going to be interesting from a financial perspective, and a lot of growth was actually projected based on SMSs, and that was skyrocketing. Then something happened, and that skyrocketing has stopped. What happened? WhatsApp happened. Today, WhatsApp is carrying more number of messages than all telecom providers combined globally. It's interesting. The point is that the pace of change is just incredible. And what was considered sort of the foundation of growth 3 years ago has simply disappeared. Right? And there are many, many, many examples. I mean, and there are many, many success stories, right? So there are everyday disruption examples that you can look at, right? From Amazon to Airbnb to Uber and others. And each one has an interesting story behind it in terms of what led to that disruption and what has actually caused that disruption to happen. If you look at Uber, it's certainly an interesting technology. It's an intelligent solution that is making it extremely easy to sort of do taxi rental or rent a car. But perhaps the biggest disruption that Uber has generated is that it has democratized, if you will, a closed system, right? So the entire supply chain of taxis was a closed system. You had to have a license to actually be a taxi driver in most large metros. And with Uber, that has been completely destroyed. The supply chain has been opened up such that anybody can become a part-time driver and actually and that has completely disrupted that industry. Right? With autonomous cars, another disruption is imminent and so on and so forth. Right? So very interesting, right? I mean, if you just look around, intelligent software is everywhere, and you're rapidly moving into what people are calling the AI first world. So I'll explain what this means in a little bit. Here are some very interesting numbers or statistics, right? Today, every 2 weeks, so S&P 500 is basically some of the largest, the top 500 companies, and every 2 weeks, a company is actually falling off that list. It's an interesting number, right? 25 of the 500 will actually no longer be there on that list at the end of 2017. And it's an alarming rate of how fast things are actually changing. The other statistics is actually, I mean, these two things corroborate well. 40% of the companies that were in the top of the top 500 in 2001 were no longer there in 2010. And several probably have disappeared completely, and several are struggling, right? So these are staggering numbers, and I don't think we have ever seen this pace of change ever in the history. So this is very, very interesting time. So the question that we should all be asking is, what is fueling this change? And we've been doing a lot of analysis of what is the heart of a lot of this change, and at least I have come to the conclusion that there are only two things that seem to be driving a lot of these companies or a lot of this change. The first one is what I would call hyper-instrumentation. Everything is actually been instrumented to a point where you have unprecedented level of visibility into any system. These systems could be human systems, these systems could be industrial systems. I mean, you talk about IoT, it's essentially giving you unprecedented level of visibility. If you look at the cell phones that all of us are carrying, the smartphones, they are heavy instrumentation of us as people, right? the mobile provider probably knows more about me, or all the apps know more about me than probably myself. I have forgotten things, but it is not forgetting. So that's a brilliant level instrumentation of each one of us, which is actually generating vast volumes of data. And I mean, you look at the entire IoT discussion, if you look at all large enterprises, data centers, networks, and so on, the level of monitoring, the level of instrumentation has gone to a point where you have immense visibility into what's happening. So that's the first thing that is actually happening across the board. The second thing that is happening is what I would call dematerialization, or software-defined everything, or there is an app for everything. Essentially what that says is that on one hand, we have created an environment which is, we have such a great level of instrumentation that is generating so much data. On the other side, we have created an ability to drive actuation in virtually anything, whether it is the door of your house, the security system, the thermostat in your house, or whatever, right? Everything there is an app for, which means there is an API for, which means that I can essentially invoke that API and take interesting actions, right? If you look at Uber, it's actually exactly these two things. If you look at the Uber app that the driver is carrying on his or her cell phone, is hyper-instrumentation, because it's using the GPS location of that car to figure out what's actually going on. And the app itself is software defined, because it's essentially is used to send commands, if you will, or instructions to the driver. And that's the combination. That's what that app is. It's actually creating instrumentation on one side, and it's creating actuation possibility on the other side. And when you combine these two things, amazing things happen, right? What this is basically enabling is the ability to create what is popularly known as cognitive solutions, cognitive systems. But essentially what they do, or what these things are that they are highly intelligent systems that have the ability to create real-time, adaptive, and personalized experiences. Right? If you look at, for example, dynamic pricing for an e-tailer is a brilliant example of exactly the same two. Hyper-instrumentation, what is the instrumentation there? Every retailer today is actually seeing and collecting vast volumes of data about every customer journey, whether it is electronic journey or physical journey in the store. And the journey breaks are essentially analyzed in real time to now determine what to do, because that's an anomaly detection that then you actually take corrective actions near real time. So each one of these examples, if you just take a step back and look at what's happening underneath the covers, it's actually exactly this two combination, right? And that is what is fueling generation of solutions that are fundamentally transforming each domain. Right, so I mean, what did Amazon do? Amazon can change prices 1 million times a day, and most retailers today struggle to change prices once a week. Exactly the same problem. No visibility, no ability to take intelligent actions. But that's what is actually resulting in substantial disruption across the board in different industries, right? So there are obviously many solutions and industries are actually getting disrupted as we speak. And there are some obviously very popular examples. I mean, automotives or driving is a great example which is actually getting disrupted. But I thought, I think this is an important slide to understand, because When people talk about cognitive solutions or cognitive systems, there is actually different levels of cognitive abilities that actually you think about. At the lowest level of sophistication are simple solutions that simply provide facts. So this is, if you will, the conventional business intelligence solutions or BI solutions, right? They basically provide facts. You can essentially search. You can do sort of interactive drill downs or whatever. It is just continuously providing you facts. That's the lowest level of sophistication. The next level up is provide suggestions. This is so your Google Maps is a great example of that next level of sophistication, where it is leveraging a lot of data that is being collected from all cell phones of the drivers to determine where there is traffic congestion, and then essentially provide inputs in terms of what road to take and how long will it take. The next level of sophistication is autonomous activities, perform a particular task. So in this example, automated parking is a perfect example of that third level of sophistication, which is using a whole bunch of sensors and actuators to perform a very well-defined task. And the most sophisticated level of cognitive solutions actually take responsibility. Right? The ability of the solution to not only understand the context, reason about that context, and take actions, decide what to do, when to do, why to do, and then take actions in order to make the system nearly autonomous. And you're starting to see, if you sort of look around, you probably have been seeing a lot of news coming in that talks about this different solutions that are emerging that are at different points in this sort of maturity levels for different domains, right? So obviously today, in automotive domain, we are definitely somewhere in getting close to this, right? But many other domains are actually not far behind, and they're all actually doing things that are actually going to, and as you can realize, if you go down this path, it is transforming everything, right? In this case, it's transforming driving experience, right? I mean, and I think in Pittsburgh, Uber has already launched these autonomous cars. So there are basically driverless Uber cars. So there are no drivers. And that has far-reaching consequences, right? This is an interesting book. I would recommend some of that you probably look at. There's a book called The Future of Professions. It's, I forget the name of the author. They are two Oxford faculty members. And it's a very interesting book because it's essentially talking about what is the implication of all of this on virtually every profession. Which profession will survive is actually a good question. With the pace at which this is actually changing is just unbelievable, right? And there are some many examples, right? So in agriculture, precision application of pesticide is actually one of the first things that you're actually starting to see. Education grading essays, all right? Legal, finding the most likely win strategy. This is actually, if you go back and if you actually look at each one of these examples, you can probably map them onto this maturity level. So if you look at, for example, legal, finding the most likely win strategy is essentially suggestive, the second level of sophistication. It's unlikely it will probably go significantly beyond that because of liabilities and so on, right? So different domains, you'll probably see this line move at different pace and probably different target point. But it's very, very interesting. Medicine, early diagnosis and treatment. Oil and gas, most of these oil and gas companies all over the world, they have these humongous, these oil rigs and these drilling machines. And first of all, they are in the middle of nowhere. There is no human in sight. And if something breaks on that machine, it is days of outage and tremendous business loss. So there, the ability to predict and prevent is actually where the whole notion of preventive maintenance, the ability to predict something is likely to go wrong based on what you're observing is actually where this is actually starting to see. And each of these problems are very complex problems but if you go back to the previous chart, they're all examples of hyper-instrumentation and software-defined everything. That combination coupled with intelligence is what is changing each of these games in an interesting manner. So with that context, I want to actually take one interesting example which all of us will immediately probably relate to. I want to take the example of the world of IT and ask, where are we? Right? And is this world of IT, the world that we all live in, the world of computing, where are we and what is the future? The first interesting point to observe is that all the things that we have talked about today, until now, are actually examples where technology or IT is at the heart of driving all these disruptions or transformations, right? Interestingly though, this combination of whether you call it IoT, network, sensors, machine learning, reasoning, smart algorithms, actuation, software-defined everything, this is all IT, right? And we are using all of this to transform everybody else's lives. It's interesting. But we are not applying that to ourselves. It's a very interesting observation. At TCS, I've been looking at this, right? If you look at every large service provider today across the globe, what we do in the world of IT, whether it is running enterprise IT, large networks, humongous storage environments, and so on, it's still very, very, very manual in most organizations. And interestingly, the reason why it is manual is, first of all, it's very complex. But we have also, in every organization, this world has been divided into so many layers and silos that everybody has only a small, narrow view of what's actually happening. So people who understand, let's say, databases, they only understand databases, nothing left of it, right of it, right? And people who understand networks only understand networks and nothing left or top or bottom. And that's actually an interesting problem, which is a big challenge, right? So this is why what is happening in our industry is that there is significant reliance on people to connect dots. But the scale and complexity of most organizations is so large that this is becoming a big challenge. In fact, this is why the way we are solving this problem today in the industry is by throwing people at the problem. You just keep throwing more and more people. As the complexity rises, hire more 10,000 people. Of course, this is a perfectly good revenue generating model for people-centric businesses. But this is exactly a problem, a domain that is interestingly ripe for disruption. Because if you once again go back to my points that I made, hyper-instrumentation, software-defined everything, IT is hyper-instrumented already, and everything is software-defined by definition. But yet, we are not able to solve the problem. Interesting, right? So there are many, there is some, I can give you many, many examples because I've seen these examples in some of the largest companies globally. So the first problem every organization sees is operational risk. Just humongously complex environments that everybody runs. Some of the large banks that I get a chance to actually look at, they run something upwards of 1 million batch jobs every night. Batch jobs are basically just standalone, if you will, applications, but they process, instead of one transaction at a time, a batch of workload. And they process, they have 1 million batch jobs with complex relationships, precedence relationships, control relationships across them. And there is no one in most of these organizations that understands the complexity or the magnitude of what they're dealing with. As a result, you always do constant firefighting. Something breaks, you throw bodies at the problem, and you hope that they can resolve. Another interesting statistics, 80 to 90% of the time it takes to resolve or repair an incident that happens in a large IT systems is actually spent in figuring out where the problem is. And in fact, you know how it works in most organizations? It is always starts out. So the common mode of operation is gather everybody who could possibly know what's happening into one room, virtual room. It is called an incident bridge. So everybody joins that call. And then you start blaming each other. And you know who gets blamed first? The network guy. It is always network guy's problem. That's number one. Then the poor guy always fights out, saying, no, it is not my problem. No, it is not my problem. He'll bring all the logs from various router switches and say, no, not my problem. Then people will say, okay, maybe it's a problem. And then, so this is the common mode of operation, right? Across the globe, you pick any company, including your own companies. Right? This is what happens today. Nobody knows, actually. So this is unbelievable, actually, staggering, these things, right? You know, 60 to 70% of the outages that happen are change-induced. Why? Nobody knows what is the impact of change. The way we call it testing, right, in computer science. We keep testing. And finally, we don't know whether we have tested. We simply give up and say, okay, enough, let it go. Right? And that's how it works. And you find out 3 days later something has gone wrong. And by the way, by that time, you've forgotten the changes you have made. Because it's not that most organizations don't make one change and wait for something to happen, right? You're introducing thousands of changes every weekend. You have no clue. What is the cause for what effect? It is virtually impossible in most organizations today to actually connect a symptom to a cause without involving exactly that room full of people, starting with networking guy. Right? This is exactly what is happening in every organization. So this is an interesting challenge for all of us, right? I mean, this is a domain, we should be disrupting it, right? But it's not that easy to disrupt. I'll tell you some of the reasons why also. Anyway, so what is everybody doing? Every organization in the world is actually facing this problem. What is everybody doing? What is generally called robotic automation, or sometimes people call it robotic process automation or run book automation or whatever. What this is actually very simple. You take a procedure for performing a complex activity, and you convert that procedure into a little program, a workflow, a set of rules with actions and so on, and you feed that into what is often called an orchestration engine. And that orchestration engine will actually execute that more or less deterministic sequence of actions when you see that particular event or task needed to be performed. And that's what essentially happens. This is, if you will, the state of the art today. So and I said about 5 years ago when I got involved and we started seeing this, and I said, this is disastrous. Why can't we actually, if IT or if technology, if computer science is used to disrupt others, why can't we disrupt ourselves? That's how we started this whole thing. And then we obviously realized that this is the state of the art and this doesn't work. Why does it not work? There are two interesting reasons that I want you to actually appreciate. The first one is that Most enterprises or most IT environments that are fueling every business today is becoming more complex by the minute. In fact, as we go to software-defined everything, right? Essentially what that does is you obviously get a lot of flexibility. You can introduce changes quickly, but it also means that everything is changing all the time. Today, just imagine when things are not changing that fine, you still are using armies of people to figure out what's happening. If everything is changing so frequently, the armies will have to multiply in order to keep up, because it's just the problem, complexity just is actually scaling through, right? Some very interesting, so when we started this journey and we looked at this sort of robotic approach, because of the diversity and complexity that exists within an enterprise, every action you perform, and that technology action may be relatively deterministic, but there is a, if you will, a judgment-based or intelligent step before you perform that action that says, what should I do? Why should I do? When should I do? And then only how should I do comes in. Right? And that part is, there are so many variants that you cannot write a program. Just imagine 1 million bad jobs. It was very interesting. One error condition in these bad jobs, that the job is running longer than expected for one of the large banks that I was dealing with. They had over 500 different scenarios. I mean, painstakingly we coded everything. We said, oh my God. By the time we finished, 100 more showed up. Right? I mean, other than guaranteeing me employment for life, it is not actually doing anything. I mean, as IT professionals, we are actually safe, because we are creating more complexity, more mess, hence more employment. But it's not really actually helping anybody. Very interesting, right? We just don't know how to deal with some of this. The second thing is actually in retrospect is sort of obvious, but it probably hit us quite badly. This whole concept of robotic automation works. And this is how actually, by the way, our automated factories work. Automated factories work on the concept of robotic automation. And that model works beautifully if what you're doing is not changing over time. Right? But if what you have to do changes every day, then the robotic automation fails. And it changes every day for us. Why? Everything changes, right? You look at a typical bank or a typical network environment, your workloads change, your attack patterns change, your underlying technology versions change, right? Even regulatory and security requirements change every day. So what used to be the procedure yesterday becomes obsolete today. And that is why you continuously rely upon people to actually solve this problem. So how do you actually solve this problem? So the basic realization was that if you just think about how our brain works, it doesn't quite work in a robotic manner. Right? Just take a very simple example. I want to meet you guys for a coffee at a Cafe Coffee Day 2 blocks from here after this. You and I don't have a procedure coded in our brains that says, how do I meet Huzur for coffee? Right? And yet I'm able to do this. Why? How? If you just think about it, our brain actually is creating the procedure for carrying out that activity on the fly by combining 3 things. First, I have the ability to become context aware. I can see, I can look around, I can know where am I. I have the ability to remember. I remember that I sort of climbed down 2 stairs to come here, so I have some notion of where am I, right? That is context awareness. The second thing that our brain uses are patterns that we learn over time. For example, let's say I'm on the 5th floor of a building and I have to go and meet him for coffee. The first pattern I have learned is that the first thing I'll have to do is go downstairs. That's a pattern. Another pattern I have learned that there are at least 3 ways of going downstairs, right? I can walk downstairs, I can take the elevator down, or I can jump out of the window. And then, of course, a pattern that we have learned is that the third option is not a good option unless the building is on fire, right? So that's patterns. And then the third thing that our brain uses are skills that we have acquired over time. I know how to walk, I know how to read a sign, I know how to pull a door, push a door, and so on and so forth. And it continuously pieces these 3 things together to construct a procedure. That's why you and I don't have to worry about how many doors will I go through, whether there will be pull doors, push doors, revolving doors, sliding doors. You basically get out, you look around, become context aware, you apply a pattern, a skill. And this is exactly what happens continuously. This is why we adapt. And yet, what we do in the world of IT is actually very robotic. Right? And that's what led us towards and potentially developing a completely different way of approaching these class of problems. So first thing we realized is that when you want to build a cognitive system, you have to go significantly beyond procedural or robotic. And there are at least 3 types of interesting activities that you and I do every day. The first one is what I would call investigative. And investigative basically says it is you are observing a symptom, you have to identify a cause and then determine an action, right? That's an investigative activity. The next one is analytical, where you basically are looking at the historical data, finding trends, patterns to identify what is likely to happen and so on and so forth. And then the last one is planning, to basically answer what if and if what questions. What happens if I introduce this change or perturbation? And if what says, if I want to accommodate that change, what should I do? This combination of activities covers 90–95% of what you and I do on a daily basis, right? And each of them actually have some sophisticated set of algorithms that are actually underneath the covers, which are a combination of machine learning, reasoning, and so on and so forth. So in fact, to build these kinds of systems, you need 3 types of intelligence. You need what I've called recognition intelligence, which is the ability to become context aware. So process large volumes of data, mostly unstructured, semi-structured, to derive interesting pieces of information from it, to basically reason about become aware of the context. The next level up is reasoning intelligence. Once you have understood, so if you look at the first category, this is exactly what you would consider, I mean, all your text mining, sentiment analysis, extraction of objects from images, videos, deep learning algorithms, and so on, they all fall in category 1. Right? The second category are reasoning intelligence, which is basically derive inferences and actionable insight. So now that I have observed something, what should I do? When should I do? Why should I do? And then the last one is operative intelligence, which is now that I've decided what, when, why, how should I actually perform an action in the context of a particular system. So that's what you need actually in order to, so if you look at this, it's an interesting amalgamation of, if you will, machine learning, a lot of pattern recognition, reasoning algorithms that traditionally you would call it, classify under a lot of the AI. And this operative intelligence is actually, it's the best way to describe it in computer science terminology would be model-driven software engineering. You want to actually take knowledge about operating in on a complex system. Basically, you want to convert everything into software-defined actions, which allow you to actually perform actions in that. And when you combine the three, you essentially get a cognitive system that is significantly and orders of magnitude away from sort of, if you will, non-intelligent system. So this is what we did with Ignio. Ignio is, as was introduced, it's essentially a cognitive platform and a specific solution that we have built for the world of enterprise IT and operations. And what it does are these four things. So in simple terms, sense, think, act, and learn. So sense is essentially what I said, the recognition intelligence. Mine lots and lots of data that is actually coming from sensors, and build a 360-degree view of the world that you're living in. It's essentially self-learned enterprise context. Think is basically reasoning intelligence, the ability to derive patterns, ability to take decisions, and then you operationalize those decisions using the act component, which is essentially the operative intelligence. And then you continuously keep learning not only what the environment is, but also the quality of your reasoning, decisions, and actions, such that you can keep improving what's actually going on. So underneath the covers, it's essentially doing these four things. But the impact is enormous, almost 10x improvement. Tenfold, we're not talking 10%, 20%, we're talking tenfold improvement in the overall quality, risk reduction, cost reduction, and so on, which is, and these are the types of things that are likely to be disrupting. And this is just example for one domain, but you'll see this happen in many other domains. And the moment you get sort of a 10x or a 5x kind of change, immediately that industry gets disrupted. And that is exactly we are more or less, I think we are all likely to see this happen in front of our eyes the next 5 years, right? And it's a little bit scary at times, but it's not a question of if this is going to happen. It's more or less a question of when this is going to happen, and that when is not that far away, which is basically. There's one other point that I want to make here, which is actually very important. I mean, being an academic and how we teach people and what should we train our people, our students, or with these kinds of systems like Ignio, Watson is another one of these, it fundamentally changes the role of people in an organization. The role of people changes from doers of work to creators and curators of knowledge. It's a completely different level of skill. To be able to actually capture knowledge and describe knowledge well is where the name of the game is likely to shift, because most of the work that people do today will actually be done by engines like Ignio come 3, 4, 5, 7 years, right? And it's a very interesting transformation. It completely changes, as I said, what we actually teach our students and so on. So let me conclude by just pointing some interesting thoughts. I think a multi-billion-dollar question, or whatever you want to call it. See, to date, if you look at this whole journey that I've talked about, and you look at every example that I mentioned, each one, including Ignio that we built for Ignio for IT operation, has taken many years of effort with a decent-sized team to get there, right? You look at what Watson is doing in healthcare. It has once again taken years of effort, hundreds of PhDs, domain experts, doctors actually working together to get it to that level of expertise. biggest opportunity and challenge that is facing all of us. And as technologists, as computer scientists, we should be asking the question, what will it take to dramatically shrink the time required to do this? Because that is what is going to happen. You cannot really do 5 years one solution, 5 years one solution. That model will not scale. Question is, what is the equivalent of a 3D printer? See, if you think about a 3D printer, right? It takes a model, 3D model as an input, and it prints a 3D object as output. What is the equivalent in the world of cognitive systems? It's actually a fascinating thought. What if I could build a cognitive system for a domain simply by describing the domain to something, pressing a button, and out pops a highly intelligent, real-time, adaptive cognitive system for that domain. Once again, it's not that far-fetched. It is not possible today, but that is the challenge that I think if we solve, it will completely disrupt many of the industries that we see around us. And that is what is the foundation of this book that I talked about, of future of professions, because many professions will disappear, new professions will come up as a result of this. Now, if you want to answer this question, I mean, I've been pondering about this and I don't have a perfect answer, but I believe that the name of the game is not technology. The name of the game is knowledge management, which most of us don't do well at. So it's very difficult for an expert to actually describe knowledge. If you go and ask somebody who's an expert in an area, tell me about that area, the person find it difficult to actually concisely describe knowledge about that domain. So how to structure knowledge about a domain, how to acquire that knowledge quickly, how to validate or verify the knowledge that you are getting about a domain, consistency, completeness, comprehensiveness. These are all hard problems, but they are essential. And last but not the least, how do you actually ensure safety? So this is why, if you look at actually what is taking so long for autonomous cars to come out, it's actually not a technology problem, it's actually a safety problem. After you have reached a certain level of maturity, the question is this safe? Can it go berserk? In fact, the number one question people ask me about Ignio when we have gone and talked to some of the largest enterprises everywhere in the world is, can Ignio bring my business down in a matter of minutes? And if so, what are the safeguards against it? So actually, when somebody asked me this question the first time, I said, well, actually, you have people running your enterprise today, and they will make mistakes, and they can bring something down. The guy thought about it for a minute and said, yes, you're right. But, you know, my people are slow. It takes them, for them to actually cause catastrophic problems, takes a long time, and before that, I will catch. Ignio will run way too fast, and that will actually bring everything down in a relatively short amount of time. So how do you actually safeguard against, what is the notion of safety? How do you prove that a system like this is safe? These are all incredibly interesting and very hard technical challenges. So my humble request to all of you is that, first of all, I think we are indeed at a very, very interesting juncture. I think if you are I've lost all my hair now, but I mean, if I was a PhD student right now or a young assistant professor, this is a phenomenal time to actually develop things that are going to completely disrupt things in the next 5 years, 10 years. You will see it in front of you, right? And in a very, 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 very short amount of time. But these problems are hard, and the consequences are actually far-reaching. So So with that, let me stop. Once again, I want to thank you very much for inviting me here, and indeed a pleasure to be back with a group of people and the sort of my, if you will, academic, close to my heart. But my world has changed, as you can see, from what I talked about today. I've gone from building network protocols and congestion control algorithms to cognitive systems, so it's a little bit removed from that. But I think it is an important point to realize for all of us that we are actually at this very interesting time, and both a threat and a significant opportunity. So thank you very much. I'll be happy to answer some questions.
Sake of a little bit more discussion, I wanted to pick on, get your thoughts on the following. So, your motivation for developing this in some IGNIO is that there is a complexity in the system, which is, for lack of a better word, that debugging problems is actually hard, right? And that's where the network guys get all the blame. So then we build another system which sits on top of it. So my guess is IGNIO at least has to be an order of magnitude more complex than what it is trying to manage. So have we just moved the complexity up, then now the IGNIO guy will get the first blame instead of the networking guy.
Yeah, that's a great question. I don't know whether I have a perfect answer. I think you're right. The only thing I can say is that a lot of these problems, if you actually look at some of these more, if you will, systems that have been designed with the principle of maintainability in mind are actually designed very differently. See, what is happening today in most organizations is that people who design are not the ones who run, and who have no idea about design, and a lot of knowledge is dropped between the two. Designs happen under assumptions of operating conditions. Those are very rarely actually captured and documented. They're lost. They're never maintained. So when something happens in run, you have no idea. So I guess the point I'm trying to make is, to answer your question, IGNIO has been in some sense designed with the concept of run in mind. So in some sense, this is actually going towards self-describing systems. See, basically, when you build anything complex, you want to actually capture enough information about that system such that you can use that self-description to actually run and feed that thing back. What IGNIO is actually doing is unearthing the self-description through a combination of machine learning and so on and so forth. And in essence, if you will, almost retrofitting an existing system with that self-learned knowledge such that it becomes self-managing, right? So that's where the game is. I'm sure that we will realize that we have not fully understood the problem yet, and I'm sure we will encounter surprises. But your point is well taken. In fact, you're right. So the second most frequently asked question about IGNIO, first is how can you prove to me that it will be safe? So actually what we have built is, actually I'll tell you interesting. We have built what we call as action firewall. You'll see my network background, right? So we have built a layer 7 firewall, essentially. And this layer 7 firewall actually captures commands. It blocks, and it actually does impact analysis in real time of that command on the entire estate and says, aha, should this be allowed or not? And if it says, no, this is too dangerous, it blocks, right? So that's how we are actually doing safety. But there is another problem, which is actually second most frequently asked question, saying this is critical infrastructure now. If it goes down, I'm dead. So the problem that you mentioned have already hit us. So now I have an IGNIO looking at IGNIO. So that's a different problem altogether. So I have 3-level hierarchy. I have a system. IGNIO is looking at the system. I have another IGNIO looking at this IGNIO to actually self-heal that IGNIO. Now, of course, you can ask what happens to that ignio. I don't have an answer yet. But that's actually, but that is the reality.
It's a good business plan, though. I think it's great for, yeah. You can sell 10 ignios.
Yes.
So changes involve people, and people are not really prepared.
Yes.
Or they are not really
Tell me about
understanding.
it.
So that creates a lot of social tension around the world.
Well, it's, I mean, yes, I think you're right. I mean, I can say that that creates a lot of tension within every organization and eventually social, absolutely. So you're right. I mean, I wish I could give you a good answer. I mean, if you're asking me the question, how can you do all of this without creating social or challenges within an organization, there is no answer. The reality is that I don't think you can stop this train. This train has left the station, and it is only accelerating. So as I think, I mean, in fact, that's why I actually gave some of the statistics of 1 out of every S&P 500 company is actually dropping out from that list every 2 weeks. The reality is actually that, right? I mean, if you look at every retailer globally, right, they are all trying to reinvent themselves because they know they are going to be out of business if they don't, right? So that is the reality, and it has implications, far-reaching consequences, no questions about it. That is why I think this community in particular has to actually start asking some of these questions, because I think 10 years from now, I think the world will be very different than it is today. I mean, just imagine, I mean, even in India, I mean, some of these consequences are quite, of course, I mean, India, autonomous cars would be a difficult challenge. I mean, because India driving doesn't not go by rules. So then it's a little difficult. You can't look at each other's eyes and decide who goes first. And that model is, I think autonomous cars will have a long way to go before that. So maybe India drivers are safe. But actually, if you just look at that, right, I mean, it's just, I mean, look at the consequences of autonomous cars on not only people, but companies, auto insurance. I mean, it's going to be I mean, it's just unbelievable number. And everybody is starting to actually rethink their business models, their people strategies in line with this. So as I said, it is not a question of if, it's only a question of when. But these are hard questions. I wish I had good answers for every question, but I mean, we are far from it.
There are possibilities that nobody will be in that train.
Nobody will be?
In that train, which has already left station.
It will be like the autonomous cars, right? I mean, it's running. There are no drivers and maybe no passengers also. I don't know. So yeah, I mean, it's an interesting challenge, but this is the reality. I mean, just look at, 2007 in some sense is an interesting year, right? First iPhone was launched. Before 2007, after 2007, the world is a different place. And today we take today's world for granted, right? And so I think this is just going to happen. It's a matter of time. So.